This is a video for AQA Further Pure Mathematics, Algebra and Graphs section 3.4, where we're looking at transformations of conics. And transformations of conics are really no different to any other graph, and you would have already perhaps considered some of these transformations, but I'm going to go through and remind you of what it means for each of these. So first of all, transforming graphs by subtracting a number from x inside the function itself or adding b. Now this is going to be a translation so that the graph moves from its position to a position which is a to the right and b up. So in fact it's moved along a vector AB. So this is the same as replacing x by x minus a and y by y minus b in the original equation. So this transformation then is a translation of the graph by a vector a, b. If we look at the graph which is formed by looking at y equals minus of f of x, then this is a reflection in the x-axis. On the other hand, if we look at f of minus x, this time this is a reflection in the y-axis. Transforming the graph by changing it from y equals f of x to x equals f of y, and this time we have a reflection in the line y equals x. Whereas if we look at x is equal to minus of f of minus y, and this time it's a reflection in the line y equals minus x. And finally look at the stretches. If we have y equals a f of x, then this is stretched by a factor of a, with the invariant line being the x-axis. So we can say that this is a stretch scale factor a parallel to the y-axis. And finally, y equals fa of x. This time you can see that it is stretched by a scale factor of 1 over a, with the invariant line this time the y-axis. So we could say that this is parallel to the x-axis. The scale factor is 1 over a rather than a. So these are all the transformations that you should be familiar with and be able to put into practice with particular equations. As an example of that, then I want to do this particular question, which says an ellipse has an equation x squared over 4 plus y squared over 9 is equal to 1, and it's translated by the vector 2, negative 2. First of all, we want to sketch a graph of the new ellipse and find the x-coordinates where it intersects the x-axis. Well, the original ellipse has equation x squared over 4 plus y squared over 9 equals 1, so that's going to cross the x-axis at negative 2 and 2, and the y-axis at 3 and negative 3. So a sketch of it would be something like this. And we're going to now translate that by a vector of 2 along and 2 down. So its top point of the ellipse is then going to be here, because the translation is by 2, -2. And so the ellipse itself is then going to come through to this point here. If we go to -2 and to this one here, and then finally the bottom point will be at -5. So the new ellipse sketch is in here. And I've got a rather better sketch of that, which is being produced by the graphing program. But we're asked then to find where the new graph crosses the x-axis. In other words, we want to find these 2 points. Well, to do that, we need to find the new equation of the ellipse. So because it's been a translation by 2, -2, we can replace x by the value x minus 2 and y by y minus -2 or y plus 2. So our new equation is x minus 2 all squared over 4 plus y plus 2 all squared over 9 is equal to 1. We want to know where it cuts the x-axis, so when y is equal to 0, in other words, we therefore have x minus 2 squared over 4 plus, when y is equal to 0, then 4 over 9 is equal to 1. We can rearrange that equation. Multiplying by 36 gives 9x minus 2 all squared plus 16 is equal to 36. And that means that x minus 2 all squared must be equal to 20 over 9. And so taking the square root of that and adding 2 means that x is equal to 2 plus or minus the square root of 20 divided by the square root of 9, which is 3. Square root of 20, of course, is 2 root 5, so we can write these points as being 2 plus 2 root 5 over 3. This one here, 2 plus 2 root 5 over 3, and the other point will be at 2 minus 2 root 5 over 3. So just running through that again then, we said we could replace values of x by x minus 2 and y by y plus 2 because of the translation. We substituted that into the equation, which then produced the quadratic which we could solve when y was equal to 0 to give us our values 2 plus or minus 2 root 5 over 3. Well, that completes this video on transformations of conics. The same techniques, of course, can be applied to any of the conics, the ellipse, the hyperbola, the parabola, or indeed the circle. In the next video, we'll be introducing the idea of polar coordinates.